So next thing we need to look at is this idea of law of cosines. So law of sines was actually pretty easy to use. There was only 4 little pieces there. The math wasn't too bad at all, but you always had to check if there was a second triangle. Law of cosines lets us do things the law of sines won't. The math takes a little bit longer. It's not any more complicated. You just got to make sure you're taking your time and showing all your work with everything. But the nice thing is you're guaranteed to just have one triangle with this. So kind of give and take with both of them. If I give you this information here, so I'm telling you side B, side C, and angle A. This is different than before because whatever angle I gave you, I also gave you that side so we could automatically set up a law of sines ratio. Okay? Even though I give you B and C, you cannot do Pythagorean theorem because these guys are not right triangles. Okay, so if it is a right triangle, law of cosines will actually work for you, but we cannot assume this guy is a right triangle. So that's out there. Okay, if you tried to set up a law of sines with this, you would say something like, okay, well, I know I have to use this sine of 40. I don't know what A is, so that's got to be a variable. I'm going to pick C with it. So C is a 4, so this is all over sine of angle C. There's 2 unknowns, there's no way you can do it. Even if you set it up with the B as well, it introduces another unknown. Okay, so we need something new here, and that is law of cosines. Okay. You're going to use law of cosines for any side, 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 or side angle side. The board's shaking here. Not really sure what's going on. Let's see if we can fix it. Okay, it must just be the wind outside shaking the building here, so hopefully you don't get seasick watching this here. So since we've kind of talked about the different cases, you'd use law of sines, law of cosines, side, 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 and the side angle side. I don't really have those memorized which ones go with which because I see what's given to me and then I match a formula up to that. Okay, the only trick now that we're introducing a new formula to you is this. If you start something in law of sines, you should stay law of sines. So that one's actually pretty easy because the law of sines is simpler for us to do. If you start in law of cosines and you find something, you have enough information now to go back and do law of sines. So we could find that missing piece there from our ratio that we had set up for this problem. But the trick with the sines is you're not sure what quadrant it's in. So the best thing I can tell you is just stay law of cosines. Okay, whatever you start with, make sure you stay with. Here's what law of cosines looks like. Okay, if you've seen it on your yellow sheet, you'll notice there's 3 different formulas for it. They're all pretty much the same. It just depends what we're trying to solve for. Some things you'll notice. This guy right here is basically just Pythagorean theorem. Okay, a squared plus b squared equals c squared. Now, the only thing the law of cosine does, and we're going to prove this tomorrow as a class, is it adds this little minus 2ab cosine of lambda on here. Okay, if you plug in a 90 for lambda, you're doing cosine of 90, which is up here. Cosine at 90 is 0. All this stuff goes away, and you get Pythagorean theorem. So really, it's just one little extension extra than Pythagorean theorem. So if you were to do a right triangle and use law of cosines, as I mentioned, this whole piece here would just go away. Okay, the other 2 versions. You got a b squared equals an a squared plus a c squared minus 2ac cosine of beta. Here's what you need to always have matched up. Whatever side is over here, the angle will be with the cosine thing. So c squared, angle c. If you get a b squared here for the side, you're doing cosine of beta. If you get an a squared here, you're doing cosine of alpha. It'll always be a Pythagorean theorem, so b squared, a squared, c squared, okay? in whatever order here, these two guys here always come from the same side. So if you're doing an a squared plus b squared, everything on this side is a's and b's, except angle C. If you're doing an a squared c squared, you have an a and a c in here. If you're doing a b squared c squared, you have a b and c in there as well. Okay, so we'll prove the formula tomorrow. We just have to be able to work with this. Okay, here's the problem then. So a triangle, kind of like what we looked at earlier, I give you two sides and an angle, but I don't give you one of the angles corresponding to the sides, so we can see why law of sines will not work for us. Okay, we don't know anything about the angles, so we have to go try and find something here. Certainly can't do Pythagorean theorem because it's not a right triangle. You know you're going to have to use the cosine of a 40. Okay, so if that's across from the A, we're probably going to use this guy right here. Okay, so I put in lambda here. That means this side over here is C. I put in beta over here, so that means this side over here is B. So I have B, I have C, I have B and C again, and I have cosine of alpha, so we're going to use that one. Now these ones here where you're finding sides are actually pretty easy setups because it's just all this math here on the right side. I'd encourage you guys to set all this stuff up and not try and do everything in your calculator, everything in your head, because if I can't follow your work, your answer is just wrong and you lose your chance at partial credit. Okay, so it's just a Pythagorean theorem minus a 2 b times c cosine down there. All we got to do is throw this in our calculator now. Again, make sure we're in degrees or it won't work at all. So okay, it's not going to be 6.6 here because that's what the a squared comes out to be. So make sure you tell me that. There's a common mistake there. Make sure you're rounding at least a couple decimal places. Now, you could go do a law of sines here. Okay, we have the opposite side, so we could go ahead and do a law of sines, trying to find this angle B down here. But like I said, once we started law of cosines, we should completely stay law of cosines. Okay, it just works best. Now that I got all the sides, I'm going to have to go do something else here. So it really won't matter which one you go to next. It's just a matter of what angle you want to find. Okay, I'm just going to pick this one. Okay, we can't use this one again because we've already used it. So now we're going to say b squared here first. So notice when I get this thing all set up, I show every step here. I didn't do the squareds or anything. So I can look right here to see if you at least have the right setup and you just screwed up the math. Now this guy's a little bit more complicated to solve. You're trying to find cosine of beta down here. Okay. It is a negative, and it's got 3 other things multiplied by it. One suggestion you can do is take all of this and swing that guy to the other side to make it positive, so you don't have to worry about the negative anymore. And then you'd move the 3 squared over to the other side as well. Now this guy here looks a little bit easier to solve, because we got our variable over here on the left. We're just going to have to do all this work here, make sure we divide by the quantity of all this junk here, and get some decimals. So we'll see you in part 2 for that.